Hello again, everyone. This is the second part of 7.5. In the previous tutorial, 7.5.1, we introduced the rule for verifying if two functions are inverses or not. Let's see how to recall using this rule. If given those two functions, f of x and g of x, and he's asking me, are the two functions below inverses? I have to plug g into f and f into g. So I'm finding the composition of f with g. Instead of this x, I'm replacing it by g of x, 2 times half x minus half plus 1. Using distributive property, 2 times half x is x, 2 times negative half is negative 1 plus 1, negative 1 and 1, 0, and it is x. When you plug f of x into g of x, this x will be replaced by 2x plus 1. So it is half 2x plus 1 minus half. Again, using distributive property, half times 2x is x, half times 1 is half, minus half. Those two will be cancelled and you're left with x. Since both the two compositions are equal to x, then yes, they are inverses. Let's now proceed in our lesson and going directly to the main objective of today's lesson, finding the inverse function. To find the inverse of a function, you have to follow those 3 steps. First of all, if given the function in the function notation f of x, you replace it with y. This is the first step. The second one, you switch x and y. If you recall our previous little activity, we started with a table and then we switched x values and y values, and we said that inverses are produced when we switch the domain and the range, which are the x and y values. And then the last step is to solve for y. Let's apply those 3 steps here to find the inverse of this given function. First of all, instead of f of x, replace it by y. And then this is the first one. The second step is switch x and y. So this y will be written as x, and this x will be written as y. To make it easier for you, I would like to make 4y plus 2 is equal to x. I just made the right-hand side on the left and the left on the right to make it easier for you to solve it for y. Of course, you can skip this step if you can do it without it. Now I'm solving for y. I will drag this 2 to this side. Let's do it here. So 4y will be x minus 2. I drag 2 to the right-hand side and I change its sign. Now the last step is to divide both sides by 4. And remember, when you divide the right-hand side, x minus 2 by 4, each term should be divided by 4. So now y is totally isolated, and x over 4 can be written as 1 over 4x minus 2 over 4, which is half. As for the last step, you can rewrite using the inverse notation. Inverse of x is 1 over 4x minus half. And this is the answer. Let's now proceed from the textbook. You can still follow the second example, page 381. Given a function f of x is equal to x plus 4, and he wants me to find its inverse. Let me remind you, the first step is rewriting. Instead of f of x, I will rewrite using y. Second step, interchange x and y, switch x and y. So this will be x and this will be y. Now you solve for y. If it's easier for you to rewrite it like this, make the left-hand side on the right and vice versa, the right-hand side on the left and the left on the right, it's easier like this, so you can isolate y easily. I'll start by dragging 4 in the other side, and now I'll divide both sides by 2. I remind you again, dividing the right-hand side, which consists of 2 terms, means each term will be divided by 2. And now the y is totally isolated, so it is y equals x over 2 minus 4 over 2. This can be written as half x. You must know for sure that x over 2 is similar, equivalent to half x. Minus 4 over 2, it is negative 2. As for the last step, use the inverse notation, inverse of x. F inverse of x is half x minus 2. And this would be the inverse of the given function. Now it's your turn. Pause the video and try to answer those 3 questions of the checkpoint. Okay, number 2. I will start by rewriting, instead of f, it will be y. And then I will interchange x and y. So it will be x is equal 4y. Then solve it for y. So y is equal x over 4, which is quarter x. As a last step, use the inverse of function notation. Number 3, I'm replacing f of x. I'm rewriting with y. Now interchanging x and y. I will choose another color. So it will be x is equal 3y minus 1. Solve it for y now. Drag the negative 1 here. Now divide both sides by y, by 3, sorry. So y will be 1 over 3x plus 1/3. Use the inverse of function notation as a last step. Number 4, again, rewrite using y. Interchange x and y. I know that I'm repeating the same steps over and over, so it will be easier for you to do it, inshallah, on your own. Now solve it for y. It's x minus 3. Now divide both sides by negative 1. So this y to be positive, or directly when you multiply the whole equation by negative 1 or divide it by negative 1, you directly change the signs of each term. Using the inverse notation, it is negative x plus 3. I hope you all did it correctly. Now let's recall an old concept which you have studied earlier when we studied the functions. This concept is called the vertical line test. And what is this test is used for? This test is used for determining whether the given graph is representing a function or not. Again, this vertical line test is used to determine whether the given graph is representing a function or not. And how do we use this vertical line test? It's very easy and very simple. If given any graph and you need to determine whether it's a function or not, you just graph a vertical line anywhere, and if it crosses the graph in more than one point, then we say it's not a function. Let's see here. This one, it crosses the graph in only one point, so yes, it is a function. Let's see the next one. The vertical line here crosses the graph in 2 points, so yes, no, it is not a function. And for the third graph, the same here. It crosses the graph in more than 1 point. Actually, it crosses this ellipse in 2 points, so it's not a function again. Now it's your turn. Pause the video and try to use the vertical line test to determine whether those three graphs are functions or not. Okay, I'll use the vertical line test anywhere to see whether it's going to cross the graph in 1 point or more than 1 point. For the first graph, it crosses it in only 1 point, so yes, it is a function. And of course, from your prior knowledge, you can see that this graph, from its end behavior, it has an odd degree and a positive leading coefficient. The second graph, it's a linear graph, it's a linear function. Without doing anything, you can determine it's a function, but let's use the vertical line test. It crosses it in only one point. Yes, it is a function. The third one, if you graph the vertical line anywhere, it will cross this circle in more than one point, actually in 2 points, so it's not a function. And maybe we have said that earlier, a graph of a circle is not a function, it is just a relation. Now, let's move on to a new concept, a little bit similar to the vertical line test, but it's called the horizontal line test. Let me repeat again. We use the vertical line test to determine whether the given graph is representing a function or not. So the question is, why do we use the horizontal line test? Actually, we use it to determine whether the inverse of the given function will be also a function or not. Let me do it with you now to make it clear for you. For this given function, the blue one, f of x, for this graph, I tried to graph a horizontal line here, and it crosses the graph in only one point. Here, exactly here, it crosses the graph in only one point. So, since the horizontal line crosses the graph in only one point, you can say that the inverse of this function will be also a function. Let's do it in the other graph here. It's a parabola, the graph, the blue one, of function g of x. And as you can see, the horizontal line here crosses the graph in 2 points, more than one. So you can determine, using the horizontal line test, that the inverse of this function will not be a function. Again, we use the horizontal line test to determine whether the inverse will be a function or not. In the first one, it crosses it in 1 point only, so we can say that the inverse is a function. While here in the next one, the function g of x, when we graphed a horizontal line, it crosses it in more than 1 point, so we can determine that the inverse of g is not a function. Now it's your turn. Pause the video and try to determine whether the inverse of those three graphs is a function or not. Now I'll do my own horizontal line anywhere of the graph. For sure, it will cross the graph in more than 1 point, so it means its inverse is not a function. The inverse is not a function. For the second graph, when you graph a horizontal line anywhere, it will cross the graph in only 1 point, so the inverse is a function. The last one, if you graph the horizontal line anywhere of the graph, it crosses it in more than 2 points, so its inverse is not a function. Let's move to the next point. Example number 3, if you're still following from the textbook, he's asking you, it's page 382, he's asking you to find the inverse of nonlinear function. But first, you have to determine whether the inverse is a function or not. How do we do that? We can graph this function and use the horizontal line test. If it crosses it in 1 point, then the inverse is a function. If not, then the inverse is not a function. Do we have to do the whole graph and make a table of values and all those stuff? No, we actually can combine our old knowledge about the end behavior. This is an odd degree, and it's a positive leading coefficient, so we know that it will be the end behavior down from here and up from here. Okay, and we can just find the y-intercept. How do we find the y-intercept? By plotting x is equal 0. So f of 0 will be 1. This will be the y-intercept. So you know that this graph is crossing the y-axis at 1, and it has this shape as any cubic function. So you just don't need to make a complete table of values and graph the whole equation. You just can use your knowledge about polynomial graphing, and you just make a sketch. Now, let's use the horizontal line test. If I graph the horizontal line anywhere, it crosses the graph in only 1 point, so it means the inverse of this function is also a function. Now the second part of the question is to find the inverse. I will start by rewriting the function using y. Now I will interchange x and y. Now solve it for y, and to make it easier for you, you can make the right hand side on the left and the other way. Now solve it for y, isolate y to the power 3, drag the 1 on the right hand side, y to the power 3 is equal x minus 1. What will be the next step? Exactly, we will find the square root of the cubic root of both sides. To get rid of this y cubic, this power 3, I will raise both sides to cubic roots. So now it is y equals cubic root of x minus 1. As a last step, you can just use the inverse of function notation instead of y. So the inverse of x will be cubic root of x minus 1. Let's move to the next example. Again, it is given a function. He wants you, a nonlinear function. It's a parabola, and he wants you to determine whether the inverse of this function is a function or not. If you're not reading the full question here, you will think it's a parabola. Yes, I know it will be like this. And yes, if I use the horizontal line test, it will cross in 2 points and the inverse will not be a function. But you really need to read the question carefully. There is such a particular domain is given here, where x is greater than or equal to 0. What does it mean? Let me erase this sketch and do the correct one. The correct graph now are for the values of x which are greater than or equal to 0. If you're using table of values, it means you can't use negative values for x. You have to start with 0 and the positive values only. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. It means when you sketch this graph, you're only sketching the right part of the parabola, because the domain is only the positive values of x, including 0. Now, this is the correct sketch. Do I have to make a table of values again? No, you just have to read the whole problem carefully. It's given a parabola x squared, but for a given particular domain, which are the positive values of x, including the 0. So this will be the correct graph. If you tried the horizontal test, it crosses it in 1 point only, so yes, its inverse is a function. Now, let's find its inverse. I'm rewriting the function. Instead of f of x, I'm using y. I need a space here. So y is equal x squared. Now, switch x and y. Now, solve it for y by finding the square root of both sides to get rid of this power 2. So y will be square root of x. And yes, it is a function. Yes, remember to use the inverse of function notation. Instead of y, I will write inverse of x. F inverse of x is equal root x. This will be the ultimate correct answer. Now it's your turn. Answer the following checkpoints. For the first one, number 5, it is again a cubic function with y-intercept -2. How did I know? I plugged x for 0 and I found that f of 0 is -2. So the sketch of this one will be with y-intercept -2, and from my knowledge about the end behavior, the graph should be something like that. If you tried the horizontal line test, it crosses it in 1 point, so yes, the inverse is a function too. Now let's find the inverse. I'm rewriting f of x with y, switch x and y, solve it for y, find the cubic root of both sides, use the inverse of function notation, cubic root of x plus 2. Number 6, again, it's half a parabola because x is greater than or equal to 1. So if you try to do a sketch of a graph, again, it's half a parabola. When you try to use the horizontal line test, it will cross it in one point only, so yet its inverse is also a function. Let's rewrite using y, switch x and y, and now solve it for y. So y squared is equal x over 9. Now find the square root of both sides. So y will be square root of x over 3. You can leave it like this or use the inverse of function notation, either to leave it root x over 3 or 1/3 root x. Both are equivalent. I hope you all did it correctly, and this will be the correct answer. See you next time, inshallah, till we meet again in our next lesson 7.6. Stay safe.